So today we're going to talk about the problems in Chapter 6 that some of you have been working on. And what we're going to be doing here is just showing you some of the problems in the percentiles. Now, it's in reverse of what we've been doing. Most of the time we have something like this. I have the probability that z is less than 1.5, and you look that up and you see whatever it is. Some probability. I think it's 0.9332, something like that. Something like that, okay? Now, what we're doing in percentiles, in this case, oops, sorry about that. I'm going to have the probability that z is less than some horizontal value from the z is equal to some probability. Okay, and this is the first one that we're going to do, but that just gives you an idea. Okay, so the number on the right-hand side is the probability, and we're going to look that up in the middle of the z table where the probabilities live. So when you think about the normal table, the values in the middle are probabilities, and the numbers on the far left-hand column and running across the top row are the horizontal values in the z. So if you look at a picture, okay, here's 0. Then the probabilities are the values up here. Okay? So I'm really looking for values between area. So when I know that most of you have forgotten your calculus, which is okay. But essentially when you're getting probability, you're getting area under a curve. So the values on the z, those are your horizontals right here. And then the values here, the probabilities, are actually the area. So what we're doing in this case, we're given the area and we're backing out that value right here. Okay? So in the first problem, they're saying the probability that z is greater than or equal to some value k is equal to 0.77. Well, we know by design, the way our table is set up, that we really don't want that. We want the probability that z is less than 1 minus that. Okay, let me put another, hang on, whoops. Well, we really want this. The probability that z is less than 0.23 or 0.2300 if you want to put it into the terms of 4 digits. Okay, so what I'm going to do is look in the middle where the probabilities are and find the closest value to 0.2300. So I'm going to scroll down through the page and look for that. Okay, so I'm looking around and I see 1977, I see 2877, well that's too high. I want 23, the closest hit to 2300. Okay, there's 2236. No, not quite. How about 2296? That looks pretty close. So I think I'm going to take that one. So what I'm going to do then is go over to the left and pick up the horizontal value. So the first part of k is negative 0.74. Sorry, negative 0.7, my fault. Well, I think I just gave you the answer away. And if you go to the top, you're going to see 0.04. We can't show the whole thing on this screen. Now, whenever the z, or the horizontal, is less than 0, you're going to actually subtract. So you're going to have 0.04, and your total is going to be negative 0.74. Okay, so your K value is minus 0.74. All right? What I'm going to do is help us find all of our Ks, and then the last part of this we're going to go back through and do the finding the X's. All right? So just hang on for a little bit on the X's. So, on problem 2, this is interesting. You want to find the probability that probability that Z is less than K is equal to 0.9. Okay, so I'm going to flip this over. So we need the next. And in that case, I'm looking for the closest value to just plain old 9, 0.9000. So I have the probability that Z is less than sorry. Let me erase that. Sorry about that. I forget I have an eraser on this. Probability that Z is less than K is equal to 0.9000. Okay. So what do? Now there's a real good one in here. Where'd it go? How about 8997? Okay, so I go to the left, I pick up 1.2, I go to the top, this time I can see the top, and I get 0.08, so K is 1.28. Pretty nice, huh? So when you're in the negatives, you subtract, positives, you add. Okay? So the rest of them, it kind of follows the same pattern. Let's see, problem 6. You're looking for, let me flip that over, sorry. 9515. So let's see if we can find that real fast while we're here in the neighborhood. 9515. Actually, we have an exact value right here. So we have 1.6 from the side, 0.06 from the roof, and we have 1.66. All right, positive 1.66. Good. So, let's do some more slides. More slides. There. Okay. So now what I'm going to do is do my X's. Who all live in Texas, right? Like the song. Bad joke. Okay. Now cast your mind back for a little bit. The dog is out there being crazy. When I do my probability in things, isn't it true that I do x minus mu over sigma is equal to z? Well, I'm going to do something similar to that to find the x values. I'm going to have x is equal to mu plus k times sigma. All right, where the k is taking the place of the z, since k is actually a horizontal z value. Nothing wrong with that. So we found the z, let's go back to problem 1. We found the z of minus 0.74. So we were given the value of 2.25 in the problem. We found z of minus 0.74 times sigma of 0.15. So we have 2.25 minus 0.11, and that's going to give me 2.14, which is what I expected. Okay? So that means that 77% or percent will contain at least whatever. That's this value, the 2.14. Okay. All right. Then for problem 2, we got our K's of 2.44. That's positive 2.44. And we have X is mu plus K times sigma. Silly me. And this is going to give me another 2.25 plus 2.44 times 0.15, and that's 2.25 plus I'm sorry, I did the wrong number here. Where did I get the 2.44 from? That's totally wrong. I'm sorry about that. Let me erase. Goodness me. What was I thinking? Alright, that's 1.28. So this is 1.28 here. And that's going to give me, that's what I was thinking. 0.19. And my final answer is 2.44. Okay, that's better. Now, they wanted between the two values. So the two values would be, of course, minus 2.44 and plus 2.44. That gives you your 90%. Okay. Then for problem 6, we're doing the old two-step process. Percentiles. So that one, we found the K of 1.66. Stop it. My computer was acting funny there for a second. And we want to find what X was. Oh, no, you didn't. We don't need that. Okay. But we do need it for problem 7. Well, I'm just lying all over the place, aren't I? Okay, for problem 7, you still had 1.28. I'm surprised you guys even believe me anymore. So you're going to have 49 plus 1.28 times 16, and that's going to be 49 plus 20.48, and that gives me 69.48. And that's it. Excuse me. Okay, hope that helps.